All right, guys, something very new today. We're going to define and use sequences and series. Just very different from what you've been used to. I think you'll like it. Sequences. A sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, I can't get a color here. Is understood the domain starts with 1. The values in range are called the terms. So, sequence, a finite sequence. First of all, domain and range. Domain is the term number. The range is the actual number, the number in the sequence. So term number in the sequence. Term number in the sequence. A finite sequence has a limited number of terms. An infinite sequence has an infinite number of terms, or it continues without stopping. So a finite sequence example might be 2, 4, 6, 8. Infinite will be 2, 4, 6, 8, dot, 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 means it goes forever. A sequence can be specified by an equation. We call it a rule. So you're going to see the word rule a lot the next few days. That just means the equation of the sequence. Both sequences above can be described by this rule. Either A sub n equals 2n, or F of n equals 2n. Either way, we're going to write this the most, probably the first way. And I'll show you how that works in just a second. So, bunch of good keywords there. You need to make sure you know those. A sequence, just a set of numbers that it's some kind of pattern. An infinite sequence goes forever, finite stops, and you write them with an equation called a rule. All right, write the first 6 terms of both of these sequences. Okay, the first one, the rule is this. A sub n equals 2n plus 5. So all you do is this. To find the first term, you're going to put a 1 where the n is. So I'm going to do 2 times 1 plus 5. That's 7. A2, do the same thing. Put the 2 where the n is. So 2 times 2 plus 5 is 9. A3, same thing. Put the 3 where the n is. And it's going to be 11. You see the pattern developing over here? A4. Put the 4 where the n was. Plus 5, that's 13. I'm going to stop at the 5th term because I'm running out of room. 2 times 5 plus 5 is 15. So look at the answers I got. 7, 9, 11, 13, 15. That is a sequence. Okay, there's an order there. The second one, I'm doing this one now. F of n equals negative 3 to the n minus 1 power. And so I'm going to plug a 1 in first. So I'm going to do f of 1. Plug 1 in there. If I plug 1 in my exponent, it gives me 0 for an exponent. Anything to the 0 power is 1. I'm going to do the same thing with 2 now. So I'm going to do negative 3 to the 2 minus 1 power. Now, 2 minus 1 is really 1. Negative 3 to the first power is negative 3. Plug in 3. Negative 3 to the 3 minus 1 power, which would really be negative 3 squared, which is positive 9. F of 4 could be negative 3 to the 4 minus 1, which would be negative 27. We'll do one more here. F of 5, negative 3 to the 5 minus 1 power, which would be 81. And look at the terms I got for my answers over here. What's happening is they're multiplying. Each term gets multiplied by negative 3 to get the next term. So there is a pattern. So my first pattern over here, I was adding 2 every time. On this side, I'm actually multiplying by negative 3 every time. So there's some kind of pattern with all these sequences. Just got to find them. All right, this slide says describe the pattern, write the next term, and then write a rule for the sequence. So the pattern I see is these are all, trying to find a color again. These are all, I'm looking at part A, these are all cube numbers. 1 cube, 2 cube, 3 cube. So that's the pattern that I see. These are all cubes. Those might be just my description. Write the next term. That's 1 cube, 2 cube, 3 cube. So 5 cubed. And they're all negative also. So my next term should be negative 125, which should be negative 5 cubed. All right, then it says write the rule. So here's what's happened. I'm seeing negative 1 cubed, negative 2 cubed, negative 3 cubed. That's my pattern. So when I write my rule, I'm just going to say, okay, it looks like it's negative n cubed. It's whatever you put in, negative, and cube it. So that's the rule. And that's all they want you to do there. Okay, second one's a little tougher. Basically what's happening is that here they added 2, here they added 4, they added 6. So they're doubling what they're adding every time. So that's one way to see it. The other way I see it is like this. That's the first term is really 0 times 1. The second term is 1 times 2. You see what's going on? Next term is 2 times 3. The next term will be 3 times 4. So I like that pattern right there quite a bit. So that's the pattern. So how do you write that? I'm going to say A n equals, if you look at my pattern, I have 0, 1, 1, 2, 2, 3, 3, 4. So the first number is 1 less than the second number. The way you write that is you write it like that. N minus 1 is 1 less than n, and that's the pattern. You're doing you're doing a number times one number less than it, or a number and a number one greater than that. Technically, you could have also written it this way. You could have gone n and then n plus 1. I think if you start with 0 right there, 0, put 1 in there. Yeah, that works also. So either way, works great. Okay, a series. Basically, a series is when they take a number in a sequence and add them together. So they're going to take a sequence, the numbers in a sequence, and add them. And the resulting expression is called a series. It can be finite or infinite. Here's a finite one: 2 plus 4 plus 6 plus 8. Infinite. ... It keeps on going. Summation notation is something probably kind of new for you. It looks like this right here. That symbol right there is called the summation symbol. And basically, I'll show you how that works on the next slide, but that's called summation. And whenever you see that, you gotta think, okay, I'm gonna add. Same thing here. Look what's on the top of that one, infinity symbol. Basically, it works like this. Whatever number's on the bottom, the 1, you take that 1 and you plug it in for the I. So 2 times 1 is 2. That's your first term. Then you plug 2 in, 2 times 2. Then you plug 3 in, 2 times 3. Then you plug 4 in, 2 times 4 is 8. And the reason the 4 is on the top, that tells you when to quit plugging things in, right? So I plug the 1 in, 2, 3, 4. Once I plug the 4 in, I'm done. And then you can add them together. The one number on the bottom is called the lower limit. Number on the top is called the upper limit. It's sigma. The symbol is called sigma. It's a Greek letter, sigma. Let's look at an example here. Okay, this one says write the series using sigma notation. So we're actually going backwards here. So if I have sigma notation, I'm going to go from 1, start at 1 here probably. Notice the sequence starts at 25. It's 25 times 1, 25 times 2, 25 times 3. It's all multiples of 25. So I'm going to put 25 in. And I'm starting with 1. Now it ends with 250. So I got to think 25 times what would be 250? Well, pretty obvious. 25 times 10 would be. So I'm going to put that. There's my summation notation. That's all you got to do in that one. Second one has fractions with it. And as I look at those fractions, I'm thinking, well, the numerator is always one less than the denominator. The denominator is always 1 bigger than the numerator. So I'm going to start with 1. And it goes forever. It's got ... So now I'm going to put an infinity symbol on the top, or the upper limit. And to write my fraction, because my denominator is 1 larger, I'm going to write the same way I did a second ago in the last slide. I'll write it this way: n over n plus 1. And you can check it by plugging numbers in. If you plug 1 in there, it'd be 1 over 2. If I plug 2 in, it'd be 2 over 3. Yeah, that works perfectly. So that's the summation notation for that one. All right, this one says find the sum of the series. I really thought they'd give you this kind first. This is actually easier than the last slide because they're giving you everything you need to just work it out. So what you do here is you start at the bottom, and I'm going to plug in the 4. If I plug in 4, I get 3 plus 4 squared, which is 19. Then I'm going to plug in the next number. I'm going to plug in the 5. 3 plus 5 squared is 28. And then I'm going to plug in the 6. 3 plus 6 squared, 39. Then I'm going to plug in the 7. 3 plus 7 squared, 52. Plug in the 8. 3 plus 8 squared, 67. Now, remember, it's a summation notation. So what I'm going to do now is I'm going to add all those. I'm adding all these up. Adding the terms up. I'm going to add all those up. Looks like I'm getting 205. So that is the answer to the summation, or the sum of that series. Okay, and on this last slide, sometimes adding up all the terms can take a long time. So here's some special ones that you'll see quite a bit that may make it quicker and easier for you to work it out or set it up. So the first one, the sum of terms of 1, of n terms of 1. If 1 is all that's there, and you're gonna add them up, whatever n is, that's what it is. So if you were to see this, if you were to see like I equals 1 to 20, and you just have a 1 right there, well, it's going to be 20 because you're basically adding 1 20 times, like 1 plus 1 plus 1 plus 1. The second one, this is if you're adding just all the positive integers. Like if you start at 1 and you're going to start adding, let's say you add up to, I don't know, the first 5 positive integers, all you have to do is put a 1 in there and, just put the numbers in there. 1 in there, so it'd be 1 times 2 over 2 to get your first term. So that's the sequence. That is the formula for the first set of positive integers, how many you're going to do. If you want the positive squares, all the squares of the positive integers, it turns into this. Okay, n plus 1, 2n plus 1, all over 6. Kind of an unusual formula there, but we'll figure out where some of those came from here in a day or two. But those are some famous ones you may want to write down. So I just want to give those to you. And I'll see you in class. We'll work on it tomorrow. See you then. I know you can't wait.